Namaste, students, and welcome. Today, we're diving into a topic from your number systems chapter that I know can feel a bit tricky. But trust me, it's actually super simple once you see the logic behind it. We're talking about real numbers and their decimal expansions. By the time we're done, you're going to feel so much more confident tackling these problems in your exams. So let's get started, shall we? So you've definitely seen numbers like these before, right? You've got 0.75, which just stops. Then there's 0.333 and so on, which seems to go on forever with that repeating 3. And then you have this other one, 1.1010001, which also goes on forever, but where's the pattern? What's the real difference here? Well, that's exactly what we're going to figure out today. Okay, so first things first. To understand these numbers, we need to talk about something called decimal expansions. Now, I know that might sound a little fancy, but it's really not. All it means is the story the number tells after the decimal point. And believe me, that's where all the secrets are hiding. All right, first up we have what we call terminating decimals. Just think of the word terminate. It means to end, right? It's like a movie that has a clear ending. When you do the division, say 7 divided by 8, you work through it and eventually, boom, the remainder becomes 0. The calculation is done. It stops. You get a nice clean answer like 0.875. Next up are the non-terminating recurring decimals. Okay, let's just break that name down. Non-terminating means, well, it doesn't end. It just keeps going. And recurring, that just means repeating, like a song stuck on a loop. The classic example is 10 divided by 3. You get 3.333, and that 3 will just keep on repeating forever and ever because the remainder never hits 0. And that brings us to our third type, non-terminating non-recurring. And again, the name tells you everything. It's non-terminating, so it goes on forever, and it's non-recurring, so there's no repeating pattern. The digits just keep coming, with no rhyme or reason. These are the really interesting ones, a very special category of numbers, as we're about to see. So you might be thinking, okay, sir, terminating, repeating, not repeating, why does all this matter? Well, here's why. Learning about these three types is the absolute key, the secret code, if you will, to figuring out if a number is rational or irrational. This is a huge concept, so let's connect the dots. And here it is all laid out for us. It's actually super simple when you see it like this. On one side, you have rational numbers. Their decimal expansions will either stop or they'll go on forever in a repeating pattern. That's it. If it stops or repeats, it's rational. On the other side, the irrational numbers. Their decimal expansions never stop and never repeat, just an endless, patternless string of digits. I would definitely take a moment to pause and write this down. It's that important.
All right, theory is great, but now for the fun part. Let's actually do something with this knowledge. We're going to tackle a super common exam question, turning one of those repeating decimals back into a fraction, the P by Q form. The steps are really logical, so just follow along with me. You've got this.
Okay, here's our problem for today. We need to show that the number 1.272727 and so on can be written as a fraction. Now, before we even start, what's the first thing you notice? Look closely. The digits 27 are repeating over and over, right? That's our repeating block. Okay, let's break this down step by step. First step is always the easiest one. We just need to give our number a name. Let's call it x. So we'll just write, let x equal 1.272727. Okay, step 2. Now, this is a common tricky point, so watch carefully. We need to multiply our x by something to shift the decimal point. But what do we multiply by? Well, we look at our repeating block. It's 27. That's 2 digits, right? So we multiply by 100. If only one digit was repeating, we'd use 10. Make sense? So multiplying by 100 moves that decimal 2 places to the right, and we get 100x equals 127.2727. Now for step 3, and this is where the real magic happens. This is the clever trick of the whole method. We're going to split our new number, 127.2727 ... into 2 pieces. The goal is to split it so that one of the pieces is our original number, x. So how can we do that? Well, we can write it as 126 plus 1.272727 ... See? So our equation now looks like this. 100x equals 126 plus 1.272727. And you see what we just did there? Remember what we called 1.272727 at the very beginning? We called it x. So we can just swap it out. We substitute x right back into the equation. So now 100x equals 126 plus x.
And just like that, the messy repeating decimal part is gone. All we have left is a simple, clean equation to solve. And from here on out, it's just basic algebra, stuff you already know how to do. We need to get all the x terms on one side. So let's subtract that x from both sides. On the left, 100x minus x gives us 99x. And on the right, we're just left with 126. So 99x equals 126. We're so close now. And for the final step, we just solve for x. We divide both sides by 99, so we get x equals 126 over 99. Now we should always simplify our fractions, right? Both of these numbers are divisible by 9. So after simplifying, we get our final answer, x equals 14 over 11. And there we have it. Fantastic job for following along.
Okay, that was great. Before we wrap up, let's do a super quick recap of the key points, and I'll give you a top tip that will really help you in your exams. So what are the most important takeaways? Just remember these two simple rules. If a number's decimal expansion stops, or if it repeats in a pattern, it is rational. And if it goes on forever without ever repeating, it is irrational. That's the whole game right there. And here's that exam tip I promised you. It's a real time saver. The number of repeating digits tells you exactly what to multiply by. If there's one repeating digit, you multiply by 10. If there are two, like in our example, you multiply by 100. 3 repeating digits, multiply by 1,000. It's a foolproof shortcut that will help you avoid mistakes. And to leave you with a final thought, a little challenge. Now that you know this method, can you try it on the number 0.999 repeating? See what you get when you convert it to a fraction. I think the answer might just surprise you. Keep practicing, everyone. You'll master this in no time. All the best.